Everything you know, everything you have ever seen, once fit inside something smaller than a grain of sand. Wild, right? The stars, the galaxies, the atoms inside your body, all of it packed into a single, unimaginably tiny point. And then boom, not an explosion like fireworks in the sky. Something even stranger. Space itself stretched. Time itself began, and the universe was born. Today, we are rewinding the cosmic clock, back 13.8 billion years, to the very first moment of creation. We will ask, how did the universe come to be? What happened in that very first second? And how do we even know? By the end, you will see how everything we are, from the air in our lungs to the stars overhead, started in that fiery moment. So, let's step into the ultimate origin story, the Big Bang. Let's start with a tricky question. What was there before the Big Bang? Well, here's the honest answer. We don't know, and maybe we can't know. Scientists talk about the universe starting from what's called a singularity, a point of infinite density where all the laws of physics break down. But here's the thing. This wasn't just a dot in empty space. It was space. There was no outside waiting around it. The universe wasn't about to explode into a void. Space itself was about to expand. And time? Same deal. Time may not have even existed before the Big Bang. Asking what came before might be like asking what's north of the North Pole. The question doesn't really work. Now, you might be wondering, did everything come from nothing? Did some cosmic spark set it off? Is our universe one bubble in a multiverse? Those ideas are fascinating, but right now, they're just speculation. What we do know is this. About 13.8 billion years ago, something happened. A moment when the universe burst into existence. And in the tiniest fraction of a second, everything changed. All right, buckle up, because the first second of the universe is a roller coaster. At 10 to the power of minus 43 seconds, we hit the Planck era. This is the earliest point we can even talk about. The universe is unimaginably hot and dense, hotter than 1 trillion stars. Gravity, electromagnetism, and the nuclear forces? They may have been one single, unified force. Physics as we know it simply doesn't apply. Then, at 10 to the power of minus 36 seconds, something insane happens. Inflation. The universe expands faster than the speed of light. Don't worry, nothing's breaking the rules. It's space itself stretching. In less than a blink, the universe goes from smaller than an atom to the size of a grapefruit. This sudden growth smooths out the wrinkles, setting the stage for a universe that looks almost the same in every direction. Skip ahead to 10 to the power of minus 6 seconds. Now we're in the quark era. Tiny building blocks called quarks are zipping around, colliding, fusing, breaking apart. Gluons, the glue particles, start binding them together. Finally, at 1 full second after the Big Bang, things settle, just a little. Neutrinos, those ghostly particles that barely interact with anything, fly off into the cosmos. The basic forces are now distinct: gravity, electromagnetism, strong and weak nuclear forces. And there it is, in 1 second flat. The universe has already laid down the foundation of everything to come. 1 second. That's all it took to set the stage for stars, galaxies, and you. The universe is now a fireball, billions of degrees hot, a dense soup of particles slamming into each other. But there's a problem. Light can't escape. Every photon, every particle of light, is instantly scattered by electrons. Imagine trying to see across a room filled with thick smoke. The light just bounces around, never making it through. That's what the universe looked like for hundreds of thousands of years. No stars, no galaxies, not even atoms yet. Just a blinding, chaotic plasma. But expansion changes everything. As space stretches, the fireball cools. Slowly, relentlessly. And as it cools, something new becomes possible. Think of steam condensing into water droplets. From formless vapor, structure begins to appear. In the same way, this fireball is on the verge of giving birth to matter. It's chaos, yes, but hidden in the chaos, order is brewing. Fast forward to about 3 minutes after the Big Bang. The universe has cooled enough for the first atomic nuclei to form. This moment is called Big Bang nucleosynthesis. Hydrogen comes first, just one proton. Then helium, with 2 protons and 2 neutrons. Tiny traces of lithium as well. That's it, just the 3 lightest elements. Now, you might be thinking, wait, where's oxygen? Carbon? Iron? Gold? Not yet. Those heavy elements don't exist yet. They'll be cooked much later, deep inside stars. But without these first, simple atoms, there would be no stars to forge the rest. By the end of this process, the universe is about 75% hydrogen and 25% helium. And here's the kicker. Those proportions match exactly what we see in the cosmos today. So in just a few minutes, the recipe for the universe is written. Hydrogen to fuel the stars. Helium to stabilize galaxies. The basic ingredients of everything. The universe is still hot, still wild. But the groundwork for creation is done. For hundreds of thousands of years, the universe is still a fog. But expansion keeps cooling it down. And then something big happens. Around 380,000 years after the Big Bang, temperatures drop to about 3,000 degrees. Electrons finally latch onto protons, forming stable atoms. And just like that, the fog lifts. For the first time ever, photons, particles of light, can travel freely. Light bursts forth across the universe. This moment left behind a signature. The cosmic microwave background, or CMB. It's the oldest light in existence. A faint glow stretched into microwaves by billions of years of expansion. Discovered by accident in 1965, the CMB is literally the baby picture of the universe. And if you look close with sensitive telescopes, you see tiny ripples. Those ripples are the seeds of galaxies billions of years later. Here's a fun fact. About 1% of the static on an old TV screen, that's the Big Bang's afterglow. You have literally seen the birth of the universe without even realizing it. This faint glow proves it. The universe really did start hot and dense, and it's been cooling and expanding ever since. So how do we know the Big Bang happened? Let's play Cosmic Detective. Clue 1. In the 1920s, Edwin Hubble found galaxies racing away from us. And the farther they are, the faster they go. That means space itself is stretching. Run the clock backward, and everything comes together in one place. Clue 2. The Big Bang model predicted a leftover glow. And sure enough, we found it. The CMB is the smoking gun, the actual afterglow of creation. Clue 3. Remember the hydrogen and helium forged in those first 3 minutes? The Big Bang predicted their exact proportions. And when we look out into the cosmos, the numbers match. Individually, these clues are interesting, but together, they make the case airtight. Expansion, ancient light, cosmic chemistry. The Big Bang isn't just a theory in the abstract. It's written into the fabric of the universe. Every galaxy, every photon, every atom carries a memory of that first moment. The universe has given us the receipts. Now, let's clear up a few myths. First, the Big Bang was not an explosion. No fireball blasting into empty space. Instead, space itself expanded, every point stretching away from every other. Second, the Big Bang doesn't say everything came from nothing. That's a deep philosophical question, not one science can answer. The Big Bang simply explains how the universe evolved from its earliest known state. And third, galaxies aren't flying through space like rockets. It's the space between them that's expanding. Like raisins baked into rising bread, they spread apart as the dough expands. So the Big Bang? Not a bomb. Not magic from nothing. Not galaxies zooming off into the void. It's stranger. and more beautiful than any of those. Even with everything we know, the Big Bang leaves us with huge questions. What caused it? Was it a quantum ripple? A bubble in a multiverse? Or is our universe part of a cycle, endlessly expanding and collapsing? We don't know. What we do know is that our current physics breaks down at the singularity. To see further back, we'll need a new theory, something that unites Einstein's relativity with quantum mechanics. But here's the wonder of it. Every answer we uncover opens new mysteries, and those mysteries drive us to keep exploring. The Big Bang isn't just science. It's philosophy. It's the story of how everything began and the questions that still keep us searching. Let's step back. From a singularity, the universe expanded. In the first second, forces and particles appeared. In minutes, the first elements formed. And after hundreds of thousands of years, light broke free. That was the Big Bang, the opening act of everything. Think about this. The hydrogen in your body comes from that first fireball. You are, in a very real way, made of the Big Bang itself. But the story isn't over. At this point, the universe was still dark. No stars, no galaxies, just endless clouds of hydrogen and helium waiting. And then the first stars lit up the cosmos. That's where we're headed next time, when the first stars were born and the darkness finally gave way to light.